All right, so we're going to look at simplifying trig expressions using our properties. This would be a good time to go grab your laminated card that's got all of those trig properties handy so that you have it to reference to. So if you need to, go ahead and pause and go hunt down your laminated card. So when you're simplifying expressions with these properties, you have to approach them as a game of logic. They're really just puzzles to see if you can decipher the code and get it down to something smaller. That's what it's all about. It's trying to take these big, complicated, scary looking expressions with all these trig things in them and using those properties, make out little swaps and substitutions that will allow that problem to condense down further and further and further to get it as small as you possibly can. Now, you might say these are hard and I don't know what to do. I don't know how to start. It's just so hard to understand them. And all I can really tell you is it's a case of practice makes perfect. The more you do of these, the easier they become, because every time you do a new one, there might be a little trick or a little pathway you hadn't thought to try that now you'll be alert to for the next time. So it's okay if they're hard. It's okay if every time you try one, you get it wrong. The idea is, what can you learn from each problem you try? What new trick can you think of to try as you move forward? That's what's going to help you get better at doing these. So here we go. We're going to work a few out and just see if we can start getting some of those tricks in line. So on the left side, I'll have the problem working through. And on the right side of that line, I'm going to give you the thought process that I would have as I was solving this problem. So the first thing I do when I look at this, I say, okay, that's tangent negative x times cosine x. So like solving an equation, the first goal I have is I'd love to get to only one trig ratio in the problem. Not a tangent and a cosine, but just tangent or just cosine, or maybe both of them need to switch out to something like sine. And if we can make the final answer just have the big threes, sine, cosine, and tangent, that just makes life easier for us as well, because sine, cosine, and tangent are on our unit circle, sine, cosine, and tangent are buttons on our calculators. If we can try to get everything to a sine, cosine, or tangent, especially sine or cosine, that's going to be a really good thing. So keep those goals in mind. Try to get one ratio, try to make it sine, cosine, or tangent. So now, as I look at this, I'm really not liking that tangent negative x. Tangent x, I can handle that, but tangent negative x, I don't like it. So I look at my properties page and I notice, hey, tangent negative x is the same as negative tangent x. So I'm going to swap. And there it is. I've swapped out that tangent negative x for negative tangent x. That just feels better. Tangent x, cosine x, these are things that we're familiar with. Now, I'm looking at it and I'm thinking there are too many trig ratios in this problem. We have tangent and cosine, that's too many. So again, I scope my properties page, I go through my brain and I remember, oh, tangent is sine over cosine. So I'm going to go ahead and change tangent to sine over cosine. So here's my swap. So I have negative sine over cosine times cosine. Hold on. A cosine on the top and a cosine in the bottom are going to divide out to 1. And again, we do make that quick statement, so long as cosine x isn't equaling 0, we can do this. We're going to make that assumption in all these problems, that if I'm going to cancel something with a denominator, if there's a trig ratio in a denominator, we're just going to assume that it never equals 0. So assuming that, I now have a cosine over a cosine, those cancel. And there I am. That's it. I've worked this problem down to a single trig ratio, one of the big three. I have negative sine x. We're done. That's pretty cool. There's nothing more I can do. Okay, let's try another one. This one's looking less pleasant. So my first thought was, yuck. However, in looking at each of those parentheses, which I really wish weren't there, it looks Pythagorean-like because I see squares and I see ones. And so I head to the Pythagorean identities section of my page to see if there's anything there that might help. And when I get there, I see, oh, 1 plus tangent squared x is actually secant squared x. And if I do a little manipulation, 1 minus sine squared x is the same as cosine squared x. Well, I'm going to go ahead and swap those out. Wow, that problem just got a lot easier, a lot faster. Once again, too many trig. I don't like having secants and cosines, and I especially don't like having secants. Secants are not one of the big three. So if I'm going to mess with anything, it's going to be that secant squared. Well, I know by definition that secant is 1 over the cosine. Therefore, secant squared is 1 over cosine squared. So I'm going to make that swap. This is looking mighty familiar. If I have 1 over cosine squared and I'm multiplying by cosine squared, then that's really cosine squared over cosine squared. And as long as cosine squared x isn't 0, those two divide out to 1. Wow, so that original problem, 1 plus tangent squared x multiplied to the quantity 1 minus sine squared x, that was really just a really obnoxious way to write the number 1? Okay, kind of cool or annoying, depending on your perspective. Let's do another one. So the first thing my thought was when I saw this problem was fractions? What? Lots of exclamation points and question marks. Like, seriously? With all of this properties, now you want to throw fractions into the mix? And so I put my foot down and said, absolutely not. I am not dealing with a fraction. So I'm going to swap that fraction out. 1 over tangent x is by definition cotangent. And you might say, yeah, but aren't you taking a big 3 and changing it into one of its other 3? Yes. However, I also noticed that the first parentheses has a cotangent in it. So by swapping out 1 over tangent, yes, I'm going to a not big 3, but I'm also making it match the other parentheses a little more closely, which might let me do something. So I'm going to make that swap. Now, in looking at this, my brain started to think this looks vaguely familiar. There's something about this arrangement of things with the parentheses, with the plus, with the minus, that seems vaguely familiar. And so I'm like, maybe I'm seeing spots, or perhaps not spots, but dots. Difference of 2 squares. It's algebra. So the secret is that I have to FOIL again. Anything I can do with algebra, like x and y, I can do with quantities like cosecant and cotangent. So I take those parentheses and I multiply them out. Now I'm able to do that just in a straight line like you see my work. Some people like to put that into that generic rectangle box to multiply. But when I multiply out, the cosecant times cotangent terms end up positive and negative. Those cancel to 0. And I'm left with cosecant squared x minus cotangent squared x. Once again, all that squaring makes me think Pythagorean. So I went to my Pythagorean section again, and I noticed that I had an identity, 1 plus cotangent squared x equals cosecant squared x. And if I just manipulate that by subtracting the cotangent squared, oh, cosecant squared x minus cotangent squared x is actually 1. Yay. Once again, I have just found another really complicated way to write the number 1. Now, as you guys are working through these problems on your own, you may find that the answers do come out to be 1 and -1 quite a bit, because I think math teachers have a really fun time trying to create different problems that eventually boil down to 1, -1, sometimes 0. That's not going to be true of every problem, but you'll find that in practice, a lot of times it does, just because of who's writing the problem. So this is your review of how to simplify with properties. Your job now is going to be just to practice. Remember, you will make mistakes. You will perhaps have fewer successes than you have challenges, but it's okay. With time and with practice, you will eventually get a hang of doing these. So good luck, and we'll see how things go.